Hey there, YouTube. It has been quite a while since I've been on here. I figured I would try to throw up another video here as I'm going through my CCNP Route studying. This is one of the labs that I have to seem to go over and over again to try to drill this into my head. Like a lot of the CCNP Route labs, it seems like you have to do them quite a few times to be able to remember all the commands that you need to do. This particular lab is the GRE over IPSEC lab. Basically, this is a pretty simple layout. You're going to have a branch router here that's passing over the your quote-unquote internet, and then going down to your HQ router here, where there's an email server hanging off of that. The quote-unquote ISP has provided two Nat Pooles, one for branch, one for HQ, both /29 Nat Poole. So what we're going to do is we're going to configure the Nat Poole onto each router here, and once we get that all configured up, we're going to configure a tunnel to go between branch to the HQ routers and be able to get that going. So I already have the basic configuration set up on each of these routers, which is just your serial connections here. The ISP has a static route pointing itself to the 209.165.200.240/29 and over to 209.165.200.224, as well as there is a default route going from the branch router pointing all zeros out to this link here, and then same deal with HQ pointing a default route going out to this link so it can at least get out to the internet. So for right now, the branch router should be able to ping most of the IP addresses here. So it should be able to ping 241, which is going to be the link here, which it should anyway because it's directly connected network. So it already knows about it, so it should be able to get to that no problem. It should also be able to get to 200.225. This is the link on the other side of the ISP router. And we should also be able to get to, it should be 226, and that would be the outside WAN interface of HQ. So for all purposes, it can ping all the way across the internet. But obviously, we want to be able to get to the internal network of the HQ so we can get to the email server. So first thing we do is set up our NAT. And we're also going to do some access lists on the NAT pools because we want to be able to translate the NAT of our internal network, the 192.168.1.0/24, to the outside, but we don't want to translate those addresses to our NAT pool going over the tunnel, and vice versa. We don't want our 10.10.10.0/24 network to be NAT translated to our 209 addresses going over to the 192 network. So in our branch router, we're going to set up our NAT pool. And let's do IP NAT pool. We're going to give it a name. So let's name it branch NAT pool, if I can type. We're going to do a start IP address, 209.165.200.249, and it's going to ask for a ending IP address, 209.165.200.254, and we're going to do a prefix length because this is /29, and we have our NAT pool in there. And so now we're going to see our interface for that come up. So now that that is up, our next thing that we're going to do is we need to be able to create the access list. So we're going to do IP access list It's going to be an extended access list, and we're going to call this, try to keep it consistent, branch Nat ACL, and we'll give this a remark. I always like to put some sort of description, remarks, and everything. That way when I go through there trying to troubleshoot, sometimes you get a little flustered. You want to have a good description of everything that is on the network. Just try to help troubleshoot things out a little bit. Makes it a little bit easier. So this is going to be, let's say, do not translate our local LAN to the HQ LAN. So we're going to do a deny 192.168.1.0. This is a wildcard. So 192.168.1.0/24. And we want to deny that going to the 10.network. And I always forget to do that. We need to deny IP. There we go. So then the next line, we're going to do another remark here. Permit. Let's do a local LAN. Translate. Local LAN to all other internet. Destination, I like it better. So we're going to do permit IP. I remember to put it in there this time. Let's see, that 1.0.0.0.0.255 to any, because we want that to be able to go to all other addresses. There we go. So now we're going to tie the access list to our Nat Poole. Since we created Nat Poole, we're going to do IPNAT inside source list, and we named this branch Nat ACL to the pool of branch Nat Poole, which is what we named up here. So now the ACL is tied to the Nat Poole, and now we're going to go to our interface loopback 1, which is simulating our internal network. And hopefully this works, because this is GNS3. I have ran across issues where the memory tends to blow up on it. Sometimes I can restart it and it'll work fine. So fingers crossed. Hey. Alright, so now we're going to go to our interface S00, which is going to be our WAN interface. I'm going to do IPNet outside. And that one is finished for now. So now let's go over to our HQ router. I'm going to move this over on this side so I can see my topology here. So now we're going to essentially do the same thing. So we're going to do Nat Poole HQ Nat Poole. So this is more consistent with the branch Nat Poole description on the other side. And this is a address of 209.165.200.233 and ending address 209.165.200.237, and this is also a prefix length of 29. So that is in there. So now we need to create our access list. Nat ACL. Again, we're going to give a remark on it. We're going to do deny 10.10.0.0 0.0.255.255 to the 192.168.1.0/24. And again, I forget to put IP in it. I'm going to have to tattoo that on my forehead so I don't forget it. Next, we're going to do remark. We're going to allow the HQ LAN to NAT to all other addresses. HQ LAN to all other internet addresses. IP 10.10.0 to any. That is in there, so we'll exit out of that. Now we will go to our list here. We're going to tie the ACL to the Nat Poole. Inside source list HQ NAT ACL to Poole HQ NAT Poole. And this is case sensitive, so if you do it all caps in your Nat Poole, you need to make sure it's caps on the ACL as well when you're binding all of this stuff. And we also need to give a static NAT for our email server, which is NAT to 209.165.200.238. So it's not part of this specific pool, so we need to give this a specific NAT as well. So we're going to do IP NAT inside source static. It's a static NAT 1-to-1 10.10.20.238 to 209.165.200.238. Yeah, 238. So there we go. So now we need to set our interfaces to IP NAT inside and IP NAT outside. So we're going to do, we need to do our loopback 1 and our loopback 0, so don't forget this one, and our S01 to the outside. Let's start with our email server. IP NAT inside. Okay. Number 1. And our interface 01 and outside. Alright. So now we have NAT set up. Now we can look at the NAT translations. Even though there's no traffic that has gone across, so we're not going to see any active translations. So we'll look at branch as well. Show IP NAT. Oh, we need statistics, not translations. So this shows our active translations. And we have a big fat 0 on there. And nothing here. That's your active translations. 1 static. So that is our email server. Other than that, we have nothing else as far as hits or anything else showing our NAT translation here. So what we can do from the branch router is give a ping to some of our addresses. Okay, as you can see, 209.165.200.238, that is our email server. And that went through, so that natted through the router over to the 10.10.20.238 via the 209.165.200.238 NAT translation. So now if we go back into our show IP NAT statistics, we should be seeing something here. to active, where are we at? Still seeing a 0 on that, which actually we should probably be looking at this side. Yeah, active translations 2. So we have one static, which is our email server, and one dynamic. We have 10 hits, 5 translated packets. So it looks like we are translating that. Now we can do the same thing from HQ. We can ping over to one of the addresses over here. Let's say ping. There's nothing really tied to it, so it's not going to respond back. We can do. No, I'm not going to really ping right now. And I'm not going to ping on that side, so we're going to have to deal with this side. Oh well. Trying to give you another thing to see as far as the NAT statistics. But not a big deal. Alright. Now what we can also do is we can do a show IP NAT translations. See nothing there. We can do the same thing over here, show IP NAT translations. Again, that's just going to show us our email server to our local address. Let's do a clear IP NAT translation. We're going to clear all these out. And what we're going to do is ping back over to 10.10.10.1 via the 192.168.1.1. And this should time out because we're essentially trying to ping an internal address that is not part of our network, nor is there a route to it. So that's going to time out. So now that means in order for our local network to talk to the other local network, now it's time that we implement our IPSEC VPN between the two sites. So this is where it gets kind of fun because there's just so many commands to put in here. It'll make you kind of bleed from the ears unless you write it down or you're constantly building these tunnels. What we used to do is when we build these tunnels, where I used to work, is we would just kind of script it. That prevent a couple of things. It would keep you from forgetting to put something in, and also it would just help with typos and anything like that. It's nothing worse than being on a production device and fat fingering an IP address or something like that, and stepping on another VPN and end up taking some stuff down. So we like to script things, but. So what we're going to do is let's start on the branch side, and we're going to start building this tunnel. So what we need to start out with is we're going to do a crypto ISACamp policy, and you have to give it a number, 1 through 10,000. Let's start at 1. We got to set our encryption. Let's do the AES. Gives you an option of how many bit keys you want to do, or you can just set it to a default. Now you need to set your authentication. We're going to set the pre-share. Here's your other ones you can do. You can set RSAs or just pre-share. We're going to do a pre-share. And you have to set to a group. I'll give it group 2. Now we're going to set the key. Choose Cisco 123. And we're going to set it to the address, which is going to be our peering address, which is the HQ WAN interface, the 209.165.200.226. Alright, that's there. So now we're going to do a crypto IPSEC transform set HQ VPN. I'm going to set ESP 3DS and we're going to do ESP SHA HMAC. Alright. Get out of that. Now we're going to do crypto map HQ map. Start with line 10. IPSEC camp. That's going to give me an error message, which is fine. That's going to be normal until we get everything else up and running here. It says it's going to remain disabled until a peer. Obviously, we don't have a peer yet because I haven't touched the other side. So now we're going to do set peer 209.165.200.226. Set transform set. We're going to tie that to HQ VPN, which is what we set up here. So we're tying everything together now, so you need to make sure everything is consistent. That way you don't end up forgetting what you set up above. Now we're going to do match address HQ VPN ACL. I was probably messing myself up doing a hyphen instead of underscore on the HQ VPN, but that's okay. Alright, so we're going to set up our ACLs as far as which addresses to trigger, what internal to what internal. So we're going to do that now. So we have IP access list extended, HQ VPN ACL, which we just named right here. And again, we're going to give it a remark. Branch to HQ to trigger VPN. And we're going to permit 92.168.1.0 wildcard to the 10.10.0.0.0.255.255. This should look familiar because we had this set to our Nat Poole ACL that we had built earlier. And like before, I forgot to put IP. One of these days I'll remember that. Alright, so we have our NAT ACL, or sorry, the VPN ACL. So we're going to exit out of that. Now we're going to go to our interface S0, I believe that's S00, yeah, S00, and we're going to set the crypto map, HQ dash map, I believe I set it to, HQ dash map, yes. Alright, ISOCamp is on, so it's saying this side is up and going. So now we need to set up the other side so we can get some VPN action going on here. So now we're going to set the same thing up on this side. We're going to do crypto ISOCamp, policy 1, encryption AES, just like the other side, authentication pre-share, group 2, like the other side, key Cisco 123. We need to make sure this matches, otherwise the tunnel will not come up, it'll fail. And we're going to set up our peer address, which is 209.165.200.242. Alright. Next, we're going to do crypto IPSEC transform set, branch VPN. We're going to set the same deal, ESP 3DS ESP SHA HMAC. And we'll exit out of that. And let's go to crypto map, branch map, line 10, IPSEC, ISACamp. Again, we're going to get the error message until we get all this up and running. And we're going to set the peer. Cut 200.242. I'm going to set the transform set. This is going to be the branch dash VPN. That's what we named up here. Again, we're going to have to set up our address. So we're going to match address, branch, VPN, ACL. So now we need to create that ACL. So IP access list, extended, branch, VPN, ACL. Go to our remark here, HQ to branch traffic to trigger the VPN. So then we got to permit this 10 dot to talk to the 192. 10.10.0.0, 0.0.255 to talk to 192.168.1.0. There we go. And I almost forgot. I didn't hit enter this time, so you can't hold it against me. There. So now we'll exit out of that. And we have to set this crypto map to our external interface. So let's go to our serial 01. And crypto map branch. Wow, I really can't type today. Branch dash map. End. ISACamp is on. Alright. So now we have that set up. Let's take a look on this side. It's probably going to give us a down on our crypto session detail. Session status down because there is no traffic passing. Just everything is not really passing, so it just hasn't had a reason to come up yet. And right now you can see the flow. This is part of our ACL to permit the 192.168.1.0 to talk to the 10 dot. Nothing is received, dropped. So now what we need to do is let's generate some traffic. So from the branch, let us ping the 10.10.10.1. And we're going to source it as a 192.168.1.1. So we generate internal to internal traffic. First ping should fail out, and the rest goes through. So now let's look up at our crypto session detail again. And now we're seeing that it is up and active. We're seeing active SAs, packets received, inbound, outbound. So everything is working. So now what we can do is do a clear crypto ISACamp. So now we've encrypted connectivity from the branch LAN to HQ LAN. The problem with an IPSEC VPN, though, is that it does not allow dynamic routing protocols to operate over it. However, we can use GRE to allow this. So now we need to set up our GRE. So first thing we want to do is let's go into our conft and we're going to create interface tunnel 0. Excuse me. So now that showed up, it's created an interface even though it is down because we have not set up anything in it. And essentially this is just a /30 address that is between our two routers here. As you see in the topology, we have 172.16.100.2, 172.16.100.1 is going to be in between this. Get the server so we can see this a little bit better. Alright, so we're going to set that. We're going to do a tunnel source of our external interface, which is the .242, so 209.165.200.242. And we need to set our tunnel destination, which is the other side, the other interface here. So 209.165.200.226. So now we have that. So now it's saying our tunnel on this side is up, even though it's not completely up because we have to set up this side. So now we'll do the same thing on this side. We're going to do tunnel interface tunnel 0. That'll create. So now we need to set our IP address 172.16.100.1/30, and then tunnel source of 209.165.200.226, and tunnel destination of 209.165.200.242. And that should come up. Alright. So now we have the tunnel up on both sides. So let's take a look at our tunnel and see what it looks like. Show interface tunnel 0. It's showing tunnels up, protocols up, so we have an up. Saying hardware is a tunnel, encapsulation tunnel, and we're saying we have GRE. So that's what we want. So now we should be able to set up some routing protocols to be able to go across this tunnel to allow our internal networks to talk. And essentially we should also be able to ping 100.1. So the other side of the GRE tunnel we are able to ping. This should show down. Such status is down. So, because tunnel's down, we're not really having a an encrypted connection because we don't have no tunnel. Alright, so in order to solve this, we're going to replace the crypto ACL to make the GRE traffic quote-unquote interesting on the branch and HQ router. So what we're going to do is we're going to do a no IP access list, no IP access list extended, HQ, VPN, ACL. That is what we set, right? HQ, VPN, ACL. So we're going to get rid of this. So now what we're going to do is IP access list, HQ, VPN, ACL. We're going to basically wipe that one out. We're going to recreate it. Extended. YouTube branch, we're going to name this GRE traffic to trigger VPN versus just HQ to branch traffic to trigger VPN, because that's all it's doing is the traffic was generating it versus this is the GRE interesting traffic. So now, instead of just permitting our specific subnet, we're going to do GRE host of our external interface to the host 209.165.200.226. So this is saying we're going to permit the host of the .242 to the host of 226, which is the WAN interface of HQ. Alright, so now we're going to do the same thing on the HQ side. I'm going to do no IP access list extended branch Nat VPN ACL. And now we're going to recreate it. IP access list extended branch VPN ACL. Remark branch to HQ. GRE traffic to trigger the VPN. We're going to do permit GRE host 209.165.200.226, which is the source on this side, to the 209.165.200.242, to which is this side over here. Oh, I forgot to put host. Alright. So now, let's try to ping 172.116.100.1 again. That goes through. So now let's take a look at our crypto. It should be up now because we're changing out the ACL to specify the tone to come up when it notices any GRE traffic. I'm going to do a show crypto session detail, and we see that our tunnel is up. So now we have encrypted traffic going between our two routers here. So now the next thing to do is we're going to try to ping the 10.10.10.1. We're going to source that from 192.168.1.1, and this should fail out. And the reason is we don't have a route yet for our 192.168.1.0 network to be able to talk to the 10. It still doesn't know exactly where it's at. So what we need to do is we created this GRE tunnel so we can have dynamic routing protocols running. So let's set up EIGRP on both of these routers to allow these networks to be able to learn about each other's networks. So we're going to do router EIGRP1, and we'll give it network 192.168.1.0. And we also need to have the 172.16.100 network. So that way we'll get a neighborship in here. 100.0. And that was a /30. So that is that. Now we need to do the same thing on this side. 10.10.0.0. Okay, and network 172.16.100.0. Okay, now we should have a neighbor come up. There we go. So now, if we look at our routing table, we now have a EIGRP route to the 10 dot network. Because we didn't have auto summary turned off, we have a /8. So let's try to ping this address again. We now have connectivity over to the 10 dot network through the branch routers. So now, say you want to do just to verify that it is going through the tunnel, we can do a trace route 10.10.20.238. We're going to source that from the 192.168.1.1. So this is going to the email server, and it's showing that it's hopping right through that tunnel. So now we have everything up and running. We have a branch network that is able to talk over to the HQ network. So now we can ping the email server. Let's source that again from 192.168.1.1. We have connectivity, so now we'd have some happy branch users because we have ability for them to work. So hopefully this helps you guys out. Again, like I said, this is one of these things that you kind of need to go through and do a few times just because there's so many steps. And I kind of walk through other things, kind of give a demonstration of how the tunnels will work as far as with and without the GRE. So this could be a little bit quicker where you guys could get a GRE over IPSEC tunnel working pretty quick. Like I said, I'm one that like to kind of script these things to make it a lot quicker, make it a little more efficient. Hopefully you guys enjoyed this. Hit me up, comments, like it, subscribe, all that good stuff. Let me know that I'm doing okay on this stuff, and I'll keep the videos coming. And always, thank you guys for watching.